I think mapping software is one of the best things we've ever done as a software industry and possibly as an entire species. Before I go too far, I'll qualify that. Obviously, the software that took us to the moon, the software that's running in my father-in-law's pacemaker, obviously that's like top tier software. But just below that, maps that tell you where you are and where you're going. That's magic. I want to show one of those to a 15th century navigator. It would blow their minds, obviously. And as well as being magical, it's like really, really useful. Obviously, the stress that's been removed from everyday life, the sense of discovery. I can find a new place in my city and not worry at all about actually being able to find it. They're brilliant. Magic software. So when this week's guest, Ian Wagner, contacted me to talk about an open source mapping library he's been working on, I thought, obviously interesting problem, obviously valuable software. Let's talk. And then I started to think about how difficult it actually must be to put this together. Because it's a deep problem, right? You've got to take mapping information and location tracking, route planning and search, and a database of interesting points along the way. And then you multiply that by the fact that it's a wide problem. We don't expect maps to just exist in one place. We want them on the web and on iOS and Android and every place that we might find ourselves lost. So it's kind of a hard problem squared of engineering. How do you do it? Well, Ian's answer is a Rust core with native shells around it. But that's too brief a summary. For the real answer, we have to get into the engineering. So let's do that. I'm your host, Chris Jenkins. This is Developer Voices, and today's voice is Ian Wagner. I'm joined today by Ian Wagner. Ian, how you doing?
Fantastic, Chris. How about you?
I'm very well. You're coming from an interesting place I don't often get guests from, right?
Yeah, I'm in South Korea. I've lived here for about 7 years now. Really, under the radar place. Not a lot of people come here to visit. But yeah, it's a really awesome place to live. My wife's Korean, which is how I ended up here. And
I see. What's it like for technology, or does it not matter because of remote working?
Well, yeah, I mean, I've been a remote worker for like 15 years now. So there is a tech scene. There's actually quite a lot of remote workers, and it's becoming more of a popular spot for digital nomads. There's a group of between 5 and 10, depending on the week, that will show up at a cafe for co-working sessions. So there's definitely a lot of location-independent tech workers here. And then the Korean companies are also starting to scale up, like Coupang, for example. They're hiring like a lot of people doing machine learning, data science, that kind of thing. So there is definitely a tech scene here. It's not quite like the US, but it's definitely growing.
Well, that always depends on where in the US you are.
Sure.
Right?
Fair enough. Yeah. Fair enough.
One thing I've learned, the United States is not really one place. It's lots of places.
Yeah, where I grew up in Pennsylvania, then there was not very much tech happening there either.
I believe. Anyway, we're not here to talk about travel, but we are kind of here to talk about travel. Ferrostar, right? For navigation. Tell me what Ferrostar is, and particularly what it isn't, because it has an interesting boundary we need to talk about.
Yeah. So, talking about like travel and navigation. You probably use Google Maps or Apple or something like that on your phone all the time.
Religiously.
When you pull it out, then one of the first things it does is it tries to figure out what your location is, like latitude, longitude. And then you've got a search box. You figure out, maybe you type in an address, maybe you type in the name of a restaurant that you want to go to, and then you select that. And then somewhere a computer figures out, how do we get between these coordinates and those coordinates? Now that's a process called routing, and there's a whole bunch of really great open source software that I think we'll probably end up talking about a little bit throughout the podcast. So that domain is called routing, and then navigation, which is what we're focusing on with Ferrostar, is how do you take that routing information and guide the user through the route. So when you start walking down the street, you get to the end of the block, and it says, turn right, and then in 50 meters, the destination is on your left. That whole kind of user experience of a user, usually on a phone, but not limited to phones, could be in-dash navigation systems in cars, things like that. So that's the part that we're concerned with Ferrostar.
So does this include or exclude the actual map layer data?
It doesn't. It doesn't include the data, but you kind of have to include a rendering package if you want to offer something that's useful for developers. Because what we're trying to do at the end of the day is build something that's useful for developers. So part of that is being able to display map data, and you can get that from any number of vendors. My company, Stadia Maps, is one of those, but the software that we're using is called Map Libre for the map rendering. Is a open source piece of software that works with Mapbox, with a whole bunch of other competitors that are using that standard format.
Okay, so the chip on my phone is telling me latitude and longitude. There's a routing service that's telling me how to get from A to B, and presumably step-by-step data for that.
Yep.
There's someone giving me map tiles.
Yep.
And Ferrostar is the bit that stitches that together into an app experience.
Exactly. You nailed it.
Right. Okay, that on the surface, let me deliberately ask a naive question. On the surface, that doesn't seem too hard because, like, zoom levels, grid, lazy loading of tiles, that seems okay. Why is it hard? Why does it seem like Google have an almost monopoly on it?
Ooh, couple of things to dive into there. One thing is the quality of it is easy on the surface. Like think about like if you had like a computer science class, you may have heard of these algorithms like Dijkstra's and A star. The actual like math behind things, the algorithms behind things, is not necessarily all that complicated. Like that's been known for a really long time. What is complicated though is building a complete experience that works for what the end user wants. So like, let's talk about the different challenges that there can be. One is on the routing side. How do you get from A to B is like, yes, you can just look at a graph with some weights or something, but that graph is actually going to be different. You're actually going to have different sets of edges that you can access if you're a car, if you're a bicycle, if you're a pedestrian, if you're a golf cart, if you're a city bus. All of these things have different kinds of access restrictions. And so part of it is being able to build an app that recognizes that. Because like in the Google Maps interface, for example, you're only getting like walking, cycling, car, and public transit, and which ones are actually available depends highly on the location that you're in. Having a good quality road network is also really important. So that's another area where things get really hard. Having good business information or addresses when you're trying to do that search for the points of interest, that's another thing.
Oh, yeah.
And different vendors actually different data sources are actually better depending on your use case. So, for example, here is kind of well known in the industry for having extremely good data for trucking, particularly in Europe. So maybe you want to take that and then combine it with maps from another vendor because you like their base map styling better. And maybe you want to have your own custom user experience on top of that. So what we're trying to do is give you the building blocks in Ferrostar that lets you do that and have a really nice app experience on all the major platforms.
Okay, so it's pulling different pieces of the puzzle together in a single combined user interface. This we can get into a few different things from that. One is just the difficulty of managing several different data feeds, right? You've got several different types of people to talk to and several different sources for each one. How many do you support? What's the job of supporting them? Is it like an endless nightmare of integration and integration tests?
It certainly could be. Fortunately, the most important parts of the stack are pretty well standardized across the
Okay.
industry. So map tiles I mentioned. There's kind of two ways you can do map drawing. One is with raster tiles, which are basically you just like download a PNG and then you say this like mosaic, this grid, and you just stitch everything together. That's the easy way. That's how things have been done in the past. Nowadays, though, excuse me, our expectations are a little bit higher. We expect to have this really nice, smooth zooming in. We don't want to see like, sharp artifacts and pixelation on the fonts as you zoom in, things
Yeah,
like
yeah.
that. So we've developed vector tiles. So there's one major industry standard called Mapbox vector tiles that I think is it's the kind of de facto standard that almost everyone uses. Google has their own proprietary one, I believe, but most of the industry is kind of standardized around Mapbox vector tiles.
So this is
Yeah,
conceptually like SVG, but
yeah. It's yeah. You could think of it like SVG in the fact that it's vector data. There's also like more rich information in there, like attributes that you can actually go in and query, which is a whole other interesting rabbit trail, I'm sure as well. So that's the quick story on the map tile side of things. On the routing side of things, there's also some level of standardization. There is one of the first open source routing engines called OSRM, which I believe stands for Open Source Routing Machine. Maybe it's OpenStreetMap Routing Machine. Yeah, I have to go look that one up later. OSRM, though, they defined a format that is very widely understood. It's JSON, and then they've basically defined a schema that everyone uses and then builds on top of to add additional things for navigation, like play this thing through your text to speech engine when you get to this point. They've developed standardized markup
oh,
languages so you can do things like the road names where I live are all in Korean. If you try running that through through an English like Siri voice, then it will. Actually, there's all kinds of weird failure modes. Like, talk about the weird edge cases. Like, that's one of them. And this is actually still a bit of an open problem for us to solve. Like, how do you recognize in the text that, like, okay, this actually needs to be spoken with a Korean voice because the English voice is just going to skip over it. So
right, yeah.
there's all kinds of interesting edge cases on the user experience there. But the response format is relatively standardized, so that's not too complicated. And then I guess finally the third thing would be on the search side. So if you're typing in like a natural string search, like an address, those are I think almost every vendor has their own API for that, but it's basically like JSON. It doesn't really matter, so it's pretty easy to write an adapter between whatever is coming in. You have some code that's like an adapter, and then it puts out some common model that then can be displayed in a user interface.
Okay. So it's not that wildly different from many kind of industrial coding projects where you've got to pull in lots of data sources and spit them out. So yeah, this is
Yeah.
not too unfamiliar to me from like working in finance, right?
Yeah. Actually, there's actually a lot of analogies there. Yeah, for sure.
Okay, the thing that makes it really different is you then have to support this over different cell phones, right? Different mobile phones. What's the
Yeah.
range of
So
coverage you got, and how do you tackle that?
yeah. So the way that this has historically been tackled is by writing a core library that has all the business logic in C++. And let me define a little bit about what that business logic is. So this would be things like you can think of the whole navigation process as like a finite state machine. You receive some kind of inputs like the user's GPS location, their compass heading, speed. You could also have different sensors in the case of a vehicle. So like say you've got like, wheel rotation sensors and things, and then those are trying to do some dead reckoning and figure out like, okay, well, actually the user is here now.
They're
Taking
doing
all
that
of
these days, actually looking at which direction your car's going in.
Yes, actually, this is actually what vehicles do. This isn't a
Oh,
problem we're tackling specifically, but this is actually what vehicles will do, and some
I
of them
didn't
even
know
have
that.
specialized hardware.
I assumed it was all based off a compass, but
You would you can actually get pretty far with that with like compass and accelerometer and things like that. You can get pretty far with that, but yeah, it can be a lot higher resolution. And you have problems like in places like Korea. Once you go underground, there's always like electrical wiring and stuff in these underground parking garages. Your car will actually work, like your GPS unit. It even has underground maps of the parking garages in many cases. So,
okay.
Yeah. So
very thorough.
Okay, where were we? We were talking about the core. Yeah.
The core business logic.
Yeah, business logic, finite state machine. You have these events coming in. You have common algorithms like snapping the user's location to a line, figuring out how far away they are from various things. How long is this line segment? These kinds of basic geometry things that you need in order to build a navigation user experience. All this stuff is normally written in like C or C++, and that's because it's portable, obviously. But we're trying to run an open source project that is easy to contribute to, and so we chose Rust for that because it's still very cross-platform. And yeah, I could talk a lot about the interesting reasons why we chose Rust. It sounded like you had a question
please.
there.
I want to know.
Yeah,
because it's the first time I've heard someone say that their first reason was for getting open source contributions.
Yes, I mean, like, yeah, and I think a lot of other people on the podcast in the past have preached the virtues of Rust. Like, it's great maintainable code, it's performance, and these are all really excellent things, really easily testable. But like trying to get people to contribute to a C++ project is that's a pretty big ask, and not just for the individuals, because most people are not professional C++ programmers, but also for the maintainers of the project. If you have a small maintainer team, it takes a lot more mental effort to review C++ code, and particularly if you want to have this, like our goals for this are pretty lofty. Like, we want this to be able to be something you can go and run in an embedded environment. And you have to make so many guarantees and so many checks about your code. If you're writing that in C and C++, it's quite a burden to maintain that kind of thing. And the difficulty of maintainers onboarding contributors and keeping the project in a correct and safe state is a lot harder. So that's one reason why I chose Rust.
Funnily enough, this morning I was looking at some C++ code for embedded hardware and trying to understand what it does, and I'm completely sold on not wanting to maintain that. Okay, so Rust cross-compilable, I can see that, very portable. It's are you therefore writing a Rust UI for Android and iOS?
I've considered that. In fact, there's some if you want to do that, there's some amazing projects you should check out. I had a couple of them written down. Crust, I believe, comes to mind, and Dioxys. Those were really fantastic. The Crust one in particular, I watched a talk by one of the creators of that or something. It was at some Rust conference, and I was just blown away by how far they had got. They built an entire, it's like Flutter or something. You like where you're writing a cross-platform framework, and like everything you can define in Rust. And I'm like, wow, that's amazing. But that's not what we're trying to do, because we want things to be able to be usable by native developers on whichever platform they're familiar with.
And
so
I'm using the Swift developer to be able to pull you in as a library. Yeah.
So the library, that's actually the exact. That's the exact pain point that we hit with most of these things. Actually, we were looking at Kotlin multiplatform as another option too. That's also definitely gaining steam. But at the time, I think this has actually changed now. So no shade on them. They were very focused around the use case of, I'm an app developer. I want to build an app that is cross-platform, not I'm a library author. I want to ship a library that works on all these platforms.
Yeah. Very different set of needs, right?
Exactly. Yeah. And Kotlin's also, by the way, really interesting, because they're also now doing with their new compiler and stuff, like WASM support is actually quite good there. So Kotlin is definitely trying to get into this space, but at the time, Rust was definitely the best option for this. And there's some really great tooling, like Mozilla is shipping some components of Firefox cross-platform, including on mobile. And so they did a lot of the work in creating these idiomatic binding generators. So the point is, we can write the core code, we can write the data types, like what is a route, what's a geographic coordinate, what's a spoken instruction, all these like core domain concepts. We can write
Right.
all these model definitions in Rust, and then on the Swift side, then you get something that feels like this was actually written by a Swift programmer. So, for example, uh, speed units. You have like kilometers and miles per hour. We would model this as an enum in like any language that has decent sum types.
Yeah.
And you can do that in Swift. So there's an enum type in Swift. Kotlin, I think it ends up as like a sealed class with different implementations or something like that. But the point is, it ends up being like completely idiomatic on the relevant platform. You can even do async, which is wild. We're not doing that at the moment, but you can do async. So you can like have an async trait or something like that. You can have an async function that you call. Traits are super cool because you can have a function interface that takes a dynamic trait, and then you can implement that in Swift or Kotlin code, which is like, just let that sink in for a second. Like, that's wild. Like, you can write
Unpack
code.
that a bit.
You can write some code in Swift or Kotlin, and you can just like pass it in as like a closure, or you can create an object that fulfills this interface. So, like in the Kotlin world, you can like implement this as a lambda that implements the single method interface. Like, that is super cool.
Okay, so you, just to make sure I've got that, you're writing a trait in Rust which defines some behavior. The Kotlin author writes some code that implements that behavior, and it gets transparently passed across to Rust code.
Exactly. As a developer, crashing. It's magic without crashing. Yeah, that's the magic. Yeah.
Yeah.
Yeah. So this lets you define, or it lets you redefine core behaviors in whatever language that you're writing in as like a mobile developer, and you don't have to wait for us for a PR, or like there are some cases, like say you've got your own proprietary routing API, or say you've got your own algorithm and your own data set for figuring out whether the user is on the route. Like, these are all just traits now in Rust, and we provide default implementations. In fact, sometimes several implementations, and you can pick from one of them. And then you can override this behavior in your app without having to like send us a pull request to like add this new thing to the core. So it's a pretty powerful system.
I'm trying to think how I'd use that in a navigation thing. So I'm writing a navigation for the Developer Voices theme park, which will be coming sometime in 2030. Could I do something like, I want to write a Swift app that plays a certain sound when your location gets close to one of my rides, I will play a certain sound that's connected to that. Is that the kind of thing we're talking about?
You can absolutely do that. Although you could have done that without our SDK. Let's make it a little bit interesting though, and refine that. So, say you want to, when the user gets close to the Tron light cycle ride, you want to play this like 80s arcade music or something, or you want to have this robo voice or whatever announcing, turn left and enter Flynn's arcade.
Right.
Like, you can do that because the text to speech trait that receives the callback basically whenever a new sound is supposed to be played, you have full control over that. So like a more realistic, a less humorous implementation would be you don't like the built-in Siri voice on your iPhone. You want to use like Amazon Polly, which has better a natural sounding voice, or OpenAI's newest thing or whatever. So you can swap all that out.
Okay, so back to bindings. You say you're using this tool from Mozilla. What's it called?
Yeah, it's called Unify, spelled like uni and then FFI as in foreign function interface.
Oh, that's clever. Okay.
Yeah, that's a clever name. Yeah. So yeah, they do most of the hard work of I write this Rust trait. There's two ways that you can define what that interface looks like. One is to use this language. It's called UDL. It stands for something description language. It's a form of interface description language. So if you ever heard of these other ones like IDL for the web, which Mozilla is also somewhat involved in, WebAssembly has some similar things going on. I believe it's called WIT for WebAssembly interface stuff. These kinds of interface description languages are not a new concept. Basically, you write something in this language that says like this is the contract, and then you have to write some code on your Rust side that fulfills it, and then their generator will consume that, and then say I have a Swift generator that consumes the UDL. I have a Kotlin generator that consumes the UDL, and then it spits out something. If that sounds a little bit complicated and I just lost you, that's true. So they've been trying some new approaches recently, and if you're a hardcore Rust programmer, you might be thinking that sounds like it should be automatable. Yeah, it turns out it is. You can automate this kind of stuff with macros. So that's the way that that things are going to be going forward, I think. So I think it's still like beta or unstable or something, but we're using it and it's fantastic. We've had very few issues with it. So now we can just write a little macro like unify export over this type, and then it's say it's a model, it exports that. We want to export this this function, this constructor. You can just do this all with macros basically, and then. So that's the Rust side of things. Then you have the binding generator, which I referred to in passing. So what that does is it goes and looks at your code in this case or whatever it generates and says, okay, now here's what I need to do to generate some Swift code. So we've got the Swift code, we've got this Kotlin code. Okay, cool. Now what? We need to actually be able to call into the Rust code. That's the part that Unify doesn't handle for you, and you have to figure out yourself. So you have to figure out all the cross-platform compilation, how to integrate it into your build system, and all that. So that's kind of the boundary there.
That's not fun. I think we might dive into that in a second. But so one of the things that always interests me in this, and we covered this, we had an episode recently talking about Python and Rust. But whenever you're compiling between two languages, the thing that gets you is the concepts that exist in one and don't exist in the other. Like, what happens when I take a callback that doesn't understand borrow checking, for instance?
Ooh, so for borrow checking, you're throwing a doozy out right away. Okay, so for borrow checking, I think the answer is they just don't let you do that in most cases.
You have to risk it being unsafe, or
no. They do everything that they can to ensure that it's safe. But that imposes some limits on the code that you are allowed to write and export over the FFI boundary.
Okay.
So, for example, they'll do some automatic bridging of strings. I would say go read the Unify guide on, like, they have a guide in MD book. They have all these internal details documented. I don't actually remember the particular details of how they do that one. Numbers, obviously, it doesn't matter. You can just copy stuff back and forth. The Unify approach, there are some ways that you could do this with just like, you could probably think like, okay, I know the Swift uses UTF-8 strings, so I can just come up with, it might just be a pure pointer, or it could be just some kind of like loose, like view proxy kind of thing that goes and points at the same memory. Unify generally tries to keep things safer rather than going for all the performance and having a risk of something going wrong. In the case of strings, I forget what exactly they do. For other cases, then I think it would basically just be like cloning it or whatever as it goes back and forth.
Okay. So do you find the experience of that as a programmer, do you find yourself restricted in what you can say in Rust in order to get it over the line?
Normally not. So they've done a pretty good job of ensuring all the common types that you would need are like bridgeable, for lack of a better term. So things like strings, things like VECA of UTF-8 or VECA of U8, so like a set of bytes, basically a byte array. So these kinds of things are all already like they do the work of bridging that for you. For other things, then it's actually kind of like this is a bit of a stretched analogy, but it's actually kind of like Serde, where you have traits that you can implement. So say I want to pass a UUID over the FFI boundary. UUID is not a bridge type. One of the ways that I could do that, though, is say, okay, I'm going to implement this this interface, and I'm gonna forget what the name of the trait is, but I can implement this, and I could just say like, okay, like write this string value for the serialization step, and then for the deserialization step, you just do like the inverse transformation.
Yeah, the old computer science trick of you can always turn it into a string and back.
Yeah, exactly.
Yeah.
You can always turn it into a string. Obviously, that's not the best. That's not the most efficient way to do things. A more efficient way would be to do like a byte array or something, because it's larger than the size of a standard integer on most platforms. But yeah.
Okay. So that's the raw talking from Kotlin, Swift, Rust. But that never quite satisfies, because what you often end up with is here you are as a Swift programmer using a Rust-based library, and everything looks rusty. If that's probably the wrong way, but everything feels like it's written by a Rust programmer. When you want it to be idiomatically Swift-like. Do you do anything for that?
Yeah, so actually Unify does some stuff for that for you automatically. So for example, a Rust function, the way that you signal an error is you return a result type. They've done a lot of work. So not only can you define your models like your structs or your enums, you can also define error types. And you can use this using these popular crates like I think Anyhow is the one that they support. Yeah, Anyhow is the one that they support. So if your error type implements Anyhow, you can just really quickly, without too much code on the Rust side, have a function that returns a result and then some error, and then it will go and recreate your, like, say, error enum with all of the different variants. Like this function could return an IO error, or it could return a parse error as error types, for example. That gets reflected then on the Swift and Kotlin side with error types. What's an error type? Well, like in Kotlin land, for example, it's going to be an exception. Kotlin functions don't return results. They return whatever the success value is, and if something goes wrong, then they throw an exception, and that's up to you as the developer to figure that out. That's not my personal favorite, but that is idiomatic Kotlin, and so that is what gets generated.
Yeah.
And similar on Swift side, Swift also has a concept of throwable errors.
Okay.
So the function will be marked as throws and so on. Yeah.
So are you saying that Unify takes care of all of the idiomaticness for you, or do you still find you end up writing like wrapper libraries, like thin things to make it feel nice?
We still have a wrapper library. So one decision that we made with the core, I call it, of Ferrostar, is to keep that pure in the functional sense. So it's pure transformations. You get some, you call with some function with some arguments, it is always going to return the same result. And then the imperative, the impure side, that's all in the platform layer on mobile. So your iOS library is going to have to keep track of, okay, a new location came in, this was the previous navigation state, now the state is this, I'm going to save that. And we don't want the end users to have to do that. So we build it's pretty minimal. It's only like a couple hundred lines of code, I think, in both Swift and Kotlin. We call it the Ferrostar core class on both iOS and Android. So there's a Swift and Kotlin class for that, and it handles, it's a little bit higher level. So it's like this class is usable for the purposes of a trip, and then you can ask it to get routes. You can it as a delegate, for example, on iOS. That's a very popular pattern in Objective C and Swiftland is the delegate pattern. In Kotlin, then it's a little bit different. Instead of having one kind of delegate, then you have all these other interfaces that you can implement, and then you can pass those off to the core class, and then you can get notified when the user goes off the route. You can implement your robotic voice to say go to the Tron arcade and things like that.
Right. Yeah. You've hit upon my favorite feature of navigation apps, which is when I go wrong, you can subtly correct without nagging me that I don't know how to read
absolutely.
maps and I'm an idiot.
Yeah, and well, actually, like this is a really interesting. We were talking about earlier, like this sounds like pretty simple. Where are all the places that it could go wrong? This is something that you might think that there's some like holy grail, some right answer for. How do we handle when the user's off route? When do we even decide when the user's off route?
Yeah.
You'd think there might be like some correct answer to that, but there isn't. It depends a lot on the context. If you're building a pedestrian navigation app and your users are in the middle of New York City with all these tall buildings, you might want to have some different thresholds, and you're not going to have the same sensors as the car. So the user's location is going to be kind of wild, going all over the place, drifting and whatever, because of the urban canyon effect of all these like tall buildings around. You can't get a very accurate GPS signal. The point at which you reroute them is probably going to be different, because like a car, when you've detected with some certainty that the car is gone the wrong way, like it's turned right and it was supposed to turn left, like there's no turning back from that. Like it's oh yep, sorry, do a U-turn or go and loop around the next block of a thing. But with the pedestrian, then maybe like that was just a spurious update and they haven't actually really moved that way down the road. And you can be a lot more lenient with the pedestrian case and like let them realize as they're looking at their phone, like, oh, actually I was supposed to go this way because I just like wasn't holding it right.
Yeah. That tricky human user interface stuff. This is something we need to get into, actually, the whole user, because I looked at the code base. You go to GitHub for an open source project and it tells you what percentage of the code is this and that and the other. And it's like, you're telling me this is a Rust core with some relatively thin auto-generated code around it. But the Rust only accounts for like 25% of your code, and most of it's Swift or Kotlin. So what are you not telling me? What is all this code that's in there?
Well, part of it is demo apps. So we do it.
Okay.
So that skews things a little bit. Part of it is... I'll try to throw too much shade, but Kotlin is a little bit verbose of a language, so like that definitely requires some extra code. You can't get around that. The other thing is that you mentioned user interface. The user interface is not in Rust. We're not doing like a Crux or Dioxys or like Slint for embedded. I hope I'm pronouncing it correctly. Where they've got the whole like user interface toolkit in Rust. So we're doing all of the UI in like Swift UI on iOS, Jetpack Compose on Android, and we're giving you a whole library of reusable widgets, because one of the problems and one of the reasons why we started this project is that the existing SDKs are like, here, we've got this like navigation experience that you can just like throw up a modal window or push it on the navigation stack or whatever, and you take that and you might have a few things that you can customize, like I want to hide this thing or I want to anchor this to a different position or something like that, but you can't really build a bespoke user interface around that. And that's what a surprising number of people that we've talked to actually want to do. So how do you do that? You can't do that super well with something like UIKit or with Android views. You can, it just gets it becomes unwieldy pretty quick. And so most people don't, most libraries don't. So what we did is with Swift UI and with Jetpack Compose, they're very composable. And so what that means is I can have a view like, let's use the map example. So the core of our navigation experience is a map. So we have a map view, and then we can kind of chain different chain or nest using different they call them trailing closures in Swift. I forget what they're called in Kotlin. But yeah, you can just like pass some additional code that then builds another view, and then it builds another view inside there, and so on. So like our map view is set up using these view builders in Swift that I can add a line on the map that shows where the route's going, and I can and like we have our own default implementation of that. But if you don't like that, you can actually take all of the pieces that we've built, not just the map view, but like the map view, you're probably going to take that as is. But then you can decide how you want to draw the line. If you want to draw a line, like there's all kinds of decisions you can make there. You can make a decision on if you want to have like zoom in and out buttons, a speedometer view, speed limit signs, and you can take all of the pieces that we've had, you can replace them with our own, you can use them, you can kind of cobble your own thing together, and you don't have to start from scratch, basically.
Can you give me an example of what you would consider to be a really bespoke experience? Because at the moment, all I can think of is my theme park, where, yeah, I'd want to add some fancy widget stuff to that. What counts as weird for you? Or novel?
What counts as weird? Okay, so I'm going to go to the absolute most minimal. I think someone actually made an app for this. Say this actually kind of works for certain like theme parks or urban environments that are super dense. Maybe actually the most useful thing for you is I just want to see an arrow telling me where I need to go next, and then like some kind of direction, maybe, or maybe the map doesn't even like appear so much until you get to a certain point or something like that. I think this could be an interesting navigation experience for all kinds of urban things. Could be really interesting for cycling if you want to have kind of a explore focus.
Yes.
Like I just want I want to get to this restaurant. I know, but like I just want to I want to just chill out, and like I want to go down this other side street like it's a new town. Like say I'm going to Amsterdam or something, and I rent a bike for the day. Like I want to see the city. Like getting to my destination is important, but it's not like the most important thing. So I could totally see some kind of local navigation experience like this being useful. I want to get in the direction of the restaurant, but
yes.
There's a cool like looking like a canal over there. I want to go check that out. Those are some cool looking houses. Yeah.
Yeah, a friend of mine's brother did a device like that called Beeline, I think it was. I don't know if it's still going, but it was you type in your destination and you just get an arrow. And the idea was that you cycle and get lost, but you'd get ever closer to where you were actually going. I can see that.
Yeah.
But that's stripped down. Have you got anything that's like richer?
Richer. Well, so I'll I don't know if anyone's actually doing this yet, but within a year or two, we will definitely have people building apps for like Vision Pro. So augmented reality kinds of experiences. Google's already doing it, and actually I think Apple is too now in certain areas anyways. With your phone, you can just hold up your phone and it's an augmented reality view. I actually think that this is going to be really useful in the future for urban wayfinding. You've got like in Seoul, you've got like all these bus stations. Some of them have the same or very subtly different names. You have a platform with the same name. It's like, this university bus station, and it's the one in the middle of the road, but which direction are you going? Like, if you're not familiar with the area, like you're there like staring at your phone and being like, okay, like is my compass calibrated right? And like, okay, so like I want to cross the road here, and this is the one that I need to get to. I think AR is actually a pretty good use case for that.
Yeah, I've used it for exactly that. It's like, and there's a lot you could do to customize that if you've got. I mean, I would have thought among the people using this will end up being tourist boards if they can get the budget to do software development, right?
Well, actually, I'm really glad you mentioned that. So one of the, like I talked about, portability to embedded devices like car infotainment systems, but another thing that we're really excited about is WebAssembly. And the reason for that is mobile developers are really expensive. Like, I get it. Not everyone, a tourism board doesn't have the budget to hire a iOS developer and an Android developer. Maybe they can manage one React Native or Flutter developer. But more likely, it's going to be a whole lot easier to find someone who just knows like some basic JavaScript and put together a web page. They've got their they've got a walking tour route planned out around like historic downtown. They've got a outdoor festival going on, these kinds of things. And we actually have a couple of customers who are interested in this use case. And building something where the core, the functional bit, is shared, all of the logic, the geometry snapping, all those things, all that's shared, and all we have to do is put a web front end around it. This makes it really easy for people to quickly put out an app that gives you this navigation experience. There are some limitations, like the web geolocation API doesn't give you background location access. So you're not going to be able to like exit out of your browser, lock your phone, whatever, and then go walk around and expect it to tell you, like you're like miles off now. It's not going to be able to do that. So there are definitely some limitations to it. But I think that navigation is very much underused by things like local tourism boards, and hopefully this will change that.
I could see it happening at tech conferences as well, because there are a lot of tech conferences with truly terrible apps.
Conference apps. Yeah,
but if they ever wanted to get their act together, being told how to get to the room that you want to be in next for the next talk would be a miracle.
Yes, it would.
And this is a place where you don't typically get navigation data inside large expo halls, right?
Well, that's an interesting one, because actually, if you pull out your iPhone, or I would assume Android as well, in an airport, for example, you probably will actually get, like, it's not going to be like really accurate, but within 50 meters or so of where your location is, even if you're deep inside the building. So Apple and Google have actually done a lot of work on indoor positioning. It's not super accurate yet. It's not accurate to the point to say like this is where your next conference room is. In the default case, it is actually possible to get a lot better though. You can actually get within, I think, like 5 meters now is the kind of standard with these like beacon approaches. So they'll install beacons throughout the building with known locations, and it is possible to do this. That's not something that we're focusing on right now, but it's definitely something possible for the future.
The future is slowly coming.
Yep.
So we need to get into the technical details of WebAssembly. Firstly, is it morally required that every single Rust project now compiles to WebAssembly?
It sure seems like it. When I first got into Rust, which was like 2017 or something, a guy who is now part of our co-working group was like evangelizing WebAssembly, and I was like, WebAssembly? What? Like, I don't get it. Like, and there was one other guy there who was doing like a game engine or something that was using WebAssembly for the back end logic, but he was talking about like, man, it's so hard. Like with WASM bindgen, you have to like do serialization across the like we were talking earlier with the FFI stuff. Like it's a whole lot worse with WebAssembly. You have to actually like, because the primitives that you have are so minimal. There's a pretty big cost to all that, and I was like, I don't get this. But I've since come around, and actually the thing I'm most excited about WebAssembly is not even on the web. I think it's the worst named technology. Well, one of the worst named technologies, because it's so much more than that. Like it's like a better abstraction than Docker for running applications in a sandboxed, architecture independent manner. Like we think of Docker as like, I have this like reproducible environment. If I am running this version of Linux and I have like access to these good disk drivers and blah blah blah. Like it's a pretty heavy thing to get that level of abstraction. Whereas I think WebAssembly does a lot better job. But yeah, it's not morally required to have every crate compiled to WebAssembly, but it turns out to be a useful property in this case, because we're also like it's a step on the way, because WebAssembly you nominally have the standard library. Slight aside on that in a second, but it's a good stepping stone on the path to no STD support, which is what you need for certain embedded platforms. Now, an interesting thing that you might not know about WebAssembly is if you look on the platform support on the Rust project, it says that the standard library is available. But there are certain things like I think it's the time APIs and the randomness APIs.
Hmm.
If you try and call those, you'll actually get a panic. So you have to bring in this like for the time stuff, you have to bring in this web time crate, and it's basically saying I can assume like it's targeting WebAssembly, but it's like I can assume that I'm running with a JavaScript interface, so I can like use these JavaScript APIs and like shim those
Oh,
in or
okay.
something.
Yeah,
So
yeah.
you have to call the version. It's like API compatible, but you have to import the web time version. So we have all these like weird conditional imports, like for the WASM 32 unknown target, which is the one um, for WASM on the web browsers. Yeah.
Of course, I didn't realize WASM was sometimes relying on being able to speak to JavaScript as well as the other way around, right? Yeah.
If you want the full standard library and you don't want WASI, the WebAssembly System Interface, which is also probably getting renamed to WebAssembly Standard Interfaces, I think, because it's more than just system interfaces. I'm actually super bullish about that whole initiative because what they're trying to do is actually using this interface description language, like I talked about earlier with the binding generation between Rust and other languages. They're trying to write something like this for gluing WebAssembly components together. And the way that they're going to do this and make it efficient is it's going to treat all of your modules together. There's some boundary that it figures out, but like you're able, if you have like multiple modules that are like linked together in order to like compose and to make some greater whole, like you've got this one module that does this one thing, and then you have this what feels like this inefficient boundary that you have to cross. It's able to actually at compile time treat those as one for compilation unit purposes, and like say like okay, like you can just like pass directly to here, so it gets more efficient. So there's a lot of cool stuff happening in that space.
Okay, okay. Is the experience of are you having a similar experience then that in that you compile your Rust to WebAssembly and then you've got to build a whole JavaScript UI toolkit around it?
Yeah, that's correct. We do have to build a whole JavaScript UI toolkit around it. Fortunately, the web side of mapping libraries is like that even predates mobile by like a decade, I think. So there's a lot of really good libraries out there.
Oh, okay.
MapLibre, there's Leaflet. There's a bunch of libraries out there that make it really easy. So the code for that is pretty minimal. We actually have an amazing student, Tingjie, who is he's in school in Canada, and he's on the Google Summer of Code grant to work on the web front end for this. So yeah, fingers crossed. In about a month or so, then we'll have something that's actually usable for these kinds of like local tourism boards and stuff.
Oh,
It's
that'd be
actually
very
all
cool.
up in the repository right now on GitHub. If you want to go check that out, I need to make it easy to like have a demo hosted on GitHub pages or something, so people don't have to download all this crap and build it themselves with WASM pack, which is that's another rabbit hole. There's the build tooling isn't it's not quite as nice as it's not quite as integrated yet, and that's mostly because I'm not a front end developer. I'm more of a mobile and back end developer. So I'd like to get a few things with the tooling. They're a lot nicer, but yeah, it's all there and documented.
It does seem like a lot of your time is going to be spent porting some UI code to this, that, and the third place and dealing with build issues. Is that your
Yeah,
life?
part of it. I'm more I would call myself the architect of how I think that this whole thing should work. So I did a lot of the implementation work on iOS, the initial implementation work on Android. I've actually done almost nothing on the web side because we've got this great student who's helping out. So my goal is to actually be like, yeah, the architect. I want to have everything in a structure where all the basics are there and everything is super easy to extend or to change the behavior or whatever. So when someone comes along and says, this thing here is like, this isn't very good. Like, this camera behavior is crap, or I don't like the look of this view, or I want to add this other new thing, or I want to add another compatibility of some other routing engine.
Mm.
I want to have all of the pieces in place so that you can go in and do that and you'll have the support that you need from all the platforms to make that happen with like just a couple hundred lines of code PR maximum. It should be really easy for you to do this because we've done all the work of having all the scaffolding in place that you can just build on. And honestly, like I think we're like 95% of the way there. It's pretty close as far as that goes. The state of the project itself, I would say it's a beta right now. We're on our fourth beta release. There are definitely things that are missing. There are definitely some weird rough edges, like if you rotate your Android device from portrait to landscape mode, it like Android's got this thing where it recreates the activity, and then basically all the state's lost, and we have to recreate things, and we don't do that very well right now. So there's gonna be a lot of things like that. This long tail of things that we can improve, but if we have the core set, that's like my job is to get the core structure of everything set for all these platforms, so that way people have also a template for what a new platform looks like. Say someone wants to come along and build a Flutter integration.
Yeah.
That's something that you could actually do now, looking at how does the web do it, how does Android do it, how does iOS do it. If I have the bits of knowledge to know how do I bridge these things to Flutter, so like how do I bridge the Rust core to Flutter, that's one thing. And I've got 3 implementations I can look at: how JavaScript, how Swift, and how Kotlin made their like wrapper interface that makes things feel native. So that's one part of things. And then 2 is knowing how the local UI works. So Flutter has their own reactive UI framework. React Native has their own thing. And so if a developer comes along that's really passionate about that, they've got the whole structure to work in, and patterns for how it should go.
Okay. Are you going to end up from that with like versioning issues? If someone wants to contribute a new UI thing for Swift, are you going to say, well, you have to write the Android version and the web version as well? Or are you going to say, well, you get different sets of features with every platform?
So there will be some different feature sets, but my goal is to keep it so that unless you're contributing like a 2,000 line feature PR for one platform, which then there's other problems. Then yeah, our goal is to keep things so that it's reasonably synced. Whether that means telling you, yeah, you have to go write this yourself, or bring in one of the other like core contributors from the project, because there's multiple of us. It's not just me. So bringing in one of the other people and saying like, hey, who's got time to go and like, I'm not a Kotlin developer, so like, okay, I want to like, I'm just going to do the iOS version and then let someone else do it for Android. So we'll figure that out as we go.
That seems like it's going to be tricky because very few people can do all 3. So you almost contributing feels like it would have to become a team effort. Not necessarily a bad thing, but a challenge.
Yeah, it's definitely going to be a challenge. It'll be interesting to see how it works. I'm so far excited by the by the interesting contribution. We'll see how it plays out after being around for another 6 months.
Okay, well, as we watch that journey, then, if someone wanted to use this, how would they? And if someone wanted to contribute, would that be welcomed? What kind of tasks are needed at the moment?
Yeah. So if you want to use it, go to GitHub. We have a full MD book, which has tutorials on how to get started with iOS and Android. Web is not documented yet, but it will be by the end of the summer. If you have questions, then we are available in a Slack channel, or of course you can always open up a GitHub issue. If you want to contribute, that's very much welcome. We've even gone so far as to flagging certain issues that are like higher priority, like this is blocking someone from doing something in production. We've also got some things that are marked as like good first issues as well as help wanted. So if you're an Android developer, for example, I think there's a couple of tasks that are like a bit more specific to the internals of Android. You could go and like poke around the help wanted tasks, and contributions are definitely welcome. I think we've had 7 people contribute so far, 3 of them fairly regularly. So contributions definitely welcome. And the more people we can get using this, like if you're building a mobile navigation experience, like I firmly believe that this project is the future as far as open source navigation solutions go. Everyone ends up solving the exact same problems, like camera issues and stuff like that. Everyone ends up solving the exact same issues. I've talked to dozens of people that are doing mobile navigation, and everyone's like, "Yeah, actually, I'm really excited about this," and half a dozen of them are already integrating them in their apps. So yeah, more
Cool.
people integrating, the better.
Well, I can promise you that one day I'm going to get absolutely sick of conference apps and think about writing a new one that actually solves the real problems people attending have. And if I hit that point,
We should collaborate on that.
We'll
I also have
collaborate.
opinions.
Yeah, absolutely. But for now, Ian, thank you very much for taking me through it.
Yeah, thanks for having me on, Chris. It was a lot of fun.
Pleasure. Thank you, Ian. I'll now have to go to my Developer Voices big map of the world and put a pin in South Korea for the first time. I wasn't expecting that one. While I'm doing that, if you want to find your way to Ferrostar's source repo, the link will be just due south of here, down in the show notes, as are links to all the other things we discussed, as always. And as you're navigating down to the show notes, should you pass the like button, the share button, the subscribe button, please give them a click. And if you find you want to do more than just click, if you really want to support, there's a link to our Patreon account, and you can sign up and get backstage news and support future episodes. And if you've already done that, thank you very much. On the topic of future episodes, if you're catching this in the week it goes out, there will be no future episode next week. It's the time of year for me to go on holiday, vacation, holidaycation. I'll be back in a fortnight. So until then, enjoy your summer. I've been your host, Chris Jenkins. This has been Developer Voices with Ian Wagner. Thanks for listening.